Welcome back to our classroom. Here we are going to discuss about some basic terms in mirrors. What are the basic terms? Yes, pole, center of curvature, radius of curvature, principal axis, principal focus, aperture. If we define principal focus, then we can define focal length of that particular mirror. Let me start with one by one. The first definition is pole. The center of reflecting surface of a spherical mirror is a point is called pole. So here I have drawn concave mirror. The inner one is reflecting surface, and that reflecting surface, this point is the center point of this reflecting surface, and this point is called pole, and the letter symbol is capital P. The second definition is center of sphere. The reflecting surface of a spherical mirror forms a part of a sphere. Yes, here we have mirror, right? If we form a sphere, this sphere will have one center, right? This center point gives center of curvature. That's why I wrote here, this sphere has a center. The center point is called center of curvature, and the symbol is capital C. The next one is radius of curvature. The radius of sphere of which a spherical reflecting surface of a spherical mirror forms a part. That means the distance between center of curvature and the pole, that will give radius of curvature. Try to understand. Center of curvature is a point. Radius of curvature is the distance between center of curvature and pole. Right? Both are different. Don't get confused. Center of curvature and radius of curvature both are equal. Radius of curvature is the distance. Center of curvature is a point. Okay. The distance between center of curvature and the pole is radius of curvature. This distance can be denoted as symbol R, capital R. And the fourth one is a straight line which is passing through a pole and center of curvature. This is a straight line. This straight line is passing through center of curvature and pole. This line is called principal axis, and there is no symbol for principal axis. The next definition, if you have number of rays, right, which are parallel to the principal axis and make the arrow mark to the from which direction to which direction it is going, right? So after it falls on reflecting surface, what will happen? The rays are reflected. The rays are reflected, and which will meet at a point on the principal axis. That point is called principal focus F. Right? That's why I wrote the reflected rays are all meeting at a point on the principal axis. This point is called principal focus of a concave mirror, and the symbol is capital F. And what is focal length? Focal length is denoted as small f. It's the distance between principal focus and pole. The focal length, small f, is the distance between principal focus and pole. Therefore, this is called focal length. The distance between principal focus and pole, that will give the focal length of that mirror. And the last one, the diameter of the reflecting surface of the spherical mirror is called aperture. These are all, diameter means this is a radius, right? Another part is also, this side also radius. C to P is radius, similarly C to this side also radius of curvature. Therefore we can write aperture is equal to 2r. Why we need to write 2r? Because the diameter of reflecting surface, this diameter of this reflecting surface of a spherical mirror is called aperture. That's why I wrote the aperture is equal to 2r. And we have one relation, r is equal to 2f. So what is r? Radius of curvature, distance between center of curvature and pole, and that is r, that is equal to 2 times of f. That means this principal focus exactly located center between pole and center of curvature. Yes, I hope you understand well. Thank you. See you in the next video.